All right, guys. So let us look at the logical standby. And okay, so let us configure the logical standby. It's been ages, guys. I have configured the logical standby. Let's see how it works. So for your activity purpose, like because I had all the notes, so I uploaded all the notes over here. And if you type logical, you should get the article converting physical standby into logical standby. The primary requirement for a logical standby is, guys, I mean, you need to configure a physical standby. So once the physical standby is configured, then it's easy to make your logical standby. And that's how all the types of standbys work. First you create a physical standby. From physical standby you can convert it into any type of standby, right? So on primary, let us connect to dgmgrl. Okay, show configuration. So what I would do is, guys, I would disable the fast start failover because it is not required, and then disable fast start failover. And this is our current configuration where you can see the IP7 is primary database and IP7 underscore STB is standby database. Don't worry about this warning. It will be, it will go off in some time because we just now disable the fast start failover. Can you see it has gone completely? So that's what I say, guys. When you're working with data guard broker, don't right away jump into finding a solution for the problem. Sometimes once the archive logs are applied onto the standby, the errors are gone, or if you rerun the commands, most of the times you will see those errors are gone. Amazing. So we have this configuration and we are trying to convert the physical standby into logical standby. So I have some queries for you guys, and I would request, like, this is something most important to the experienced DBS. So in primary database, you need to retrieve the list of objects that are not supported by logical standby, and this command will give you all those lists. And guys, one more thing that is not supported by logical standby, because now that I get it, it is like it needs all the records inside primary must be uniquely identifiable, unique records. That means in primary, if you have a table where there is no primary key, then that table will not be part of the replication or the standby. That is also a big challenge. So that means every table in primary needs to have a primary key column. So in primary database, retrieve the list of objects that are not supported. If you execute this command, you have to run this in primary, guys, because on primary we need to understand what objects are not supported. You can see DBA log standby unsupported. This is the dictionary table. But because we are working on almost blank database, because there is no user data, in real time you might definitely see a big list of unsupported objects. Now you can also check the reason behind those unsupported objects, and that is done by this next query. So what you can do is select column name data type from this log standby unsupported, where from the above query you will get the owner name and you will get the table name. Find out those objects why they are not supported. So I've given an example, like if the owner is OE and customer table is not supported, then you can run this query to find out the issue, and then you might fix it. Let's take if on that table there is no primary key, it will give you like what is the issue. Depending on the issue, what you can do is you can recreate a primary key on the table, and then maybe this table is supported. So you have to analyze all the objects out of this query, and depending on those objects, if you're okay, you can skip some objects, or if you want those tables, then definitely you need to dig deep to understand what is the reason why it is not supported. So tables is one issue, guys. There might be, so tables is like objects, and the other issue is the unsupported schemas. So there are a lot of internal schemas on primary that will not be supported. because any changes on those internal schemas will not be replicated on standby. For example, when we talk about physical standby, guys, everything is replicated. That means all the sys user changes are also replicated. But on a logical standby, the sys user is the first user which is not at all supported, because this database is an open read write. The sys user will work independently over here, and this sys user on primary will work independently on primary. So because of this, lot of internal schemas are not supported. So how do you know the list of unsupported schemas? You run this command and find out. Over here also, the output that you see, these all are internal schemas which you get free when you install the Oracle database. But what you need to make sure is there is no client schema that is coming over here, because if you have a client schema, then it becomes a challenge. And the next one is, you need to make sure that the primary database can, all the records in the primary database is uniquely identifiable. So this query will give you all the tables where you have an issue with the unique column name. So if there is a table where you don't have a unique column, it will give you the information over here, and then you can definitely attack it and kind of like change it or add a primary key. So these steps are very important in primary. If your client is okay with all the objects, unsupported schemas, and if there is any other issue which you have already fixed, then you can move ahead to create or build a logical standby. So our configuration, how it looks like, I sometimes feel, guys, when we are learning something, there should be, like how I draw these diagrams, I feel half of the screen should have these kind of drawings saying like, okay, now this is the configuration, this is how things look at the outside world, because it makes life simple. So this is primary, this is standby, everything is working fine. Primary is up and running, standby is up and running. We have a client which is connected to primary, right? What we are trying to do is we are trying to convert this physical standby into logical standby. So when we convert this into logical standby, what happens at this stage? At this stage, there is a background process which is known as log miner is started. So this log miner, the job of the log miner is very simple. Whatever redo is coming from the primary, the log miner will convert it into SQLs. Technically, these are known as LCR. Like each SQL statement will be converted into a logical change record. I mean, that's how we refer to an SQL statement once it is coming out of the log miner. Now, after the LCRs are created, this is created in the database buffer cache. After the LCRs are created, these LCRs are arranged in the order of execution, like dependency. So because sometimes one SQL needs to execute before you can run the other SQL, right? So create table must execute before the inserts are executed. So the LCRs are rearranged based in the order of dependency. And once they are grouped together based on the dependency, the SQLs are run against the logical standby database. And that's how each statements are added to the logical standby server. So this log mining and converting of these SQLs and running them against the database is actually an overhead. It's extra burden onto the standby server. So this is also one more reason a couple of people don't choose the logical standby database. All right, so that's our configuration. Now, before you can convert the physical standby into a logical standby, we need to stop the MRP. Now we have the data guard configured, guys. So what we will do is we will stop the apply off from the data guard broker, and let us look at it. Let me check the sync of the databases. Archive log list. All right, so currently it's at 8, and switch user hyphen Oracle scale plus slash SysDBA, select process status sequence number from v dollar managed standby. All right, we can see it's applying the log number 8, alter system switch log file. All right, now it is applying log number 10. That means our setup is working perfectly fine. Let us connect to DGMGRL because we are using DataGuard broker. So we will stop the MRP from the DataGuard broker. Okay, show configuration. All right, IP7 is primary, IP7 STB is physical standby. Show database IP7 underscore STB. Now IP7 STB, you can see apply is on. So alter database IP7 underscore STB set. Okay, I'm not sure about the command set state. Yeah, state equal to apply hyphen off. Alter. Oh, it's not alter database. Edit database. Sorry, guys. This is what happens if you are not in touch with the technology. So apply hyphen off. Let us look at the database standby configuration. We can see the apply is set to off. Perfect. And if you want to confirm, we'll just go to the database and I'm running this. You can see MRP was earlier running. Now applying is stopped, right? So everything is fine. And at this stage, we need to build the logminer directory on the primary. So this logminer directory is created. Actually, it has to be created on both the servers, but on standby, it will be automatically created later on because you perform the switchover. So at both the location, this directory needs to execute. So this directory is where the reader. Okay, guys, I think I forgot to walk you through the architecture of the logical standby. So what happens in logical standby, like internal architecture, you have redo data, or I would say redo entries from primary, right? These redo entries are coming from primary. So once they land onto the standby server, what happens is there is a reader process. Now these all are part of your log miner. Okay, log miner. So this reader process will read redo records and it will pass all this, or it will actually put it onto the preparer. This is the preparer process. The preparer process will, like, reader is getting from the primary and it is handing over all the redo data to the preparer. So we have multiple preparer processes because when a lot of redo is coming in, the log miner needs to work extra in order to convert those redo data into the SQL statement. So by default, Oracle has, or the log miner will have more number of preparer processes. These preparer processes will actually read the redo data and convert it into LCRs. What is an LCR? All the SQL statements that are recreated from the redo, it has a fancy name, that is logical change record. After the LCRs are created, they go to the builder. So this is another process inside the log miner. So what builder will do is it will group the transactions. Okay, so transaction grouping happens over here. This LCRs are individual SQL statements. All right, so now you might say, like, okay, what is the problem over here that the builder has to group the transactions? See, if this preparer process number 1, this is process number 2, process number 3. So preparer process number 1 got this SQL statement insert. All right, and preparer number 3 is having the SQL statement create table. All right, so when LCRs are created, let's take preparer process 1 was pretty fast. So this statement was written first and preparer 3 was little slow. So the create table statement was next. Now in this kind of situation, we know that this SQL will fail because if the table is not created, this SQL will fail. So the builder technically it groups the transactions. Okay, let's take some transactions that are to be executed on HR schema. All the HR transactions will be grouped together out of these LCRs. All the Scott transactions will be grouped into one. The builder will perform a group based on the schema on which it has to execute, and after that we have an analyzer process. The analyzer process will sort the data, sort based on dependency. Sorry guys, so it will sort based on the dependency. In this case, this statement, the create table, needs to be executed first, the insert must be executed second. This is the job of the analyzer. Analyzer will switch the order of the transactions based on the dependency. Once this is done, you have a coordinator process. So the coordinator process is the one which will execute these transactions in a batch onto the database, and it will send one batch to the database, but it is not directly sent to the database. After the coordinator processor, you have an applier processor. So these appliers also, we have couple of processes, like you can also increase the applier processes, and these applier processes will execute the statements against the database. This is how the exact architecture works. Now this log mining happens at an OS level directory, and it creates the log mining happens inside the database, guys. So for this, it needs a special area inside your database where it is able to perform all these activities. So that's the reason you need to build this directory inside the database. And how it is done, we have inbuilt utility. You don't kind of like manually do it. If you execute this command, automatically it will build the log miner directory inside the database where log mining can happen. So at this stage, if you look at this one, we have stopped the physical standby, the MRP process. We are now going to build the log mining directory on the primary. So select name, comma, open underscore mode from $, database. So this is our main database. Now I am building this directory. Log mining happens on standby, okay? But what if you perform a switchover? Then you need it on primary also, right? So this is done. All right, so log mining directory has been built. Now in future, if you perform a switchover on this server also, we need a log mining directory, right? Otherwise the switchover will fail. So now we can happily open the physical standby database. So on the standby database, you can specify alter database recover to logical standby. So this way you are converting it into logical standby and give a name to this database, and this name will be exactly same as the standby name that we are using. So this is the standby server, alter database recover to logical standby, IP7 underscore STB. Before that, I want to check where the client is connected. Client is connected on IP7. I will not run this command. I will select name, comma, open underscore mode, comma, what is that? Database role from $, database. So this is our IP7 database, which is mounted and physical standby. Guys, in your practice, you learned something. You have a different name, not the name. I think your instance name is different. Don't worry about if you feel any change over here. I think I confused you guys. So now forget about it. We are converting this physical standby into a logical standby, and the database name is going to change over here. This is what I want to bring your notice to. So currently the database is IP7, and the database name will completely change because database is getting a new identity. It's a new individual independent database. So hit enter, and then you'll have to wait until this is converted into logical standby.
Arun, you didn't do the log switches after building the directory.
No, you don't have to do. This is what is more important over here. If you see this one, we have stopped the apply. The building has to be done. And I'll tell you what, if the log switch is, if the apply is not switched off at this stage, you will never be able to build the logical standby. So this log standby build directory will be auto created on your logical standby. You don't need to worry about it. But before you switch the log file and apply it onto the standby, the problem is you need to first convert it into logical standby. So now that it is converted into logical standby, of course, we will be starting the LSP process. Once you start the LSP process, this logical standby will be auto created onto your standby directory. Sorry, logical standby directory will be created on logical standby database. So if you
Okay, all right,
skip this step, if you skip this step, trust me, you will never be able to build the logical standby. These two are very critical. I can bet on it. It's my experience, and I have spent like hours understanding, because what happens is, if what you said, if you do that, this command will hang forever, and you will never be able to convert it to logical standby. And that's the reason you build the log standby directory before that you stop the MRP, you build the directory, then you convert it into a logical standby, and once you start the LSP, this directory will be auto built on the logical standby. You don't have to worry about it. All right, so can you see our database is now converted to the logical standby? So this command converts your physical standby into logical standby, just one command. But if you see guys, we have converted the physical standby into logical standby. But once this conversion happens, your instance will be in a different state. So what you need to do is you need to shut down your instance and open the database. A logical standby runs in an open mode. And opening the database also, we need to perform a reset logs. Why we do it, I'll tell you in a minute. All right, so startup mount. So guys, this database is a completely new database for the outside world. Okay, so this database was in a recovery mode for a long time. So now you need to open this database in the reset log modes so that this database can get a new incarnation, it can get a new identity. It is a unique database in an environment, and that's the reason the database needs to be in a reset log modes. This is like one dimension. The other dimension, if you see, let me explain you guys. The second dimension why reset log happens is you have a primary database, and for a physical standby database there is a special type of control files that are used. So each database, we know we have parameter file, then we have control files and data files. So the control files that are used for the physical standby are special type of control files. So when you convert physical standby into logical standby, the database will make changes to this control file. All right, because now this database is going to have its own unique identity. It will be a completely new database for the outside world. So if you make any changes to control files, you always use open reset logs. I'm telling this from the experience of database recovery. So internally, because there has been a change inside the control file, so you need to open the database in reset log modes. So now that we have mounted the database, we open it into, sorry, startup mount. And now this becomes a completely new, different database from your primary database. So it's like a completely new database, but in the background it will be constantly applying the logs that are being received from the primary database. Those logs will be converted into SQLs. Those SQLs will be applied onto this database constantly. At this stage we can check the status of this database. Guys, it will take some time, so don't worry. Now can you see? Okay. So guys, as I mentioned, the database name will change because it is getting a new identity. All right. So the database name, the unique name will become same. Earlier, the database name was same as the primary database name, but in a logical standby, it is a unique database. So its name will become same as your DB unique name or whatever you specify over here. Can you see? Whatever name you will specify over here, your logical standby will take that name. But it is always good to specify the DB unique name so that you are inconsistent, right? And you can see database role is logical standby. All right. The guard status, as I mentioned, I'll talk in some time. So before we get on to the guard status, we need to make some changes to the data guard broker. Remember guys, we had the broker configuration already, and we have DG broker. Inside the data guard broker, we have both primary and standby. Physical standby was registered. So what we have to do is we have to deregister the physical standby, and we have to tell that broker, hey, we have a new logical standby database, so that the broker is now able to manage both your like the primary and the logical standby. So this is something we have to do, and that's the reason we have to make changes to the data guard broker. So first of all, we have to remove the earlier physical standby database from the data guard broker. You have to do it on the primary server. Sorry. Connect to the DGMGRL utility or the data guard broker. Type show configuration, and inside this configuration, of course, now there will be a lot of errors. So best part is you just remove the database, remove database, because it was earlier physical standby. So this is a challenge. We need to edit this property guys, until unless we edit the property, because for IP7 underscore STB is fast start failover target. Remember we set this property while configuring the FSFO fast start failover. So edit database IP7, set property, set this property to blank. Okay, now for this database there is no fast start failover target. So now we can remove this database from our configuration. Remove database, because there is no point in keeping this, as our data guard broker is still assuming that it is physical standby database. So once you have removed this, show configuration, can you see we are left with the primary database. Now we need to add our logical standby to this configuration. And how it is done? So on the, before you apply or add the logical standby to your broker configuration, you need to enable the LSP process, the logical SQL apply process. That's how it has a typical name guys. So the command to enable the LSP process on standby is alter database, start logical standby apply, and then immediate. So this will start the LSP process immediately on your logical standby database. This is our logical standby. So I will start the LSP process. All right. And Now you can happily add your IP7 underscore STB to your data guard broker configuration. So add database IP7 underscore STB connect identifier. Connect identifier is IP7 underscore STB. I'm very bad with these commands, guys. So add database IP7 underscore STB as connect identifier is IP7 underscore STB. The database is added to your configuration. Check the configuration again. Can you see IP7 underscore STB logical standby database? It is disabled. You need to enable the database. We have just added the database. Once you enable, then only data guard broker will be managing both the databases. So you can see the next command that we have, enable database. You need to give the database name. Amazing. You can see show configuration. So IP7 underscore STB logical standby database has been added. As I always say, ignore warnings. Don't act until it's an error. All right. So how do you verify the logical standby database? Because see, we have enabled the LSP process. The problem with logical standby is inside the v dollar manage standby, like select process comma status sequence number from v dollar manage standby. In this one, earlier we could easily see the MRP process, right? But this LSP process is an OS level process. It is not started inside the database. Of course, there are queries we will look at inside the database. But in general, if you want to check the LSP process, you can check it via the OS level. Sorry, this is, yeah, PSI funny crypt pmon. Sorry. So this LSP process, guys, can you see? We are having two LSP processes running in the background, and don't worry, it is completely like it is taken care by your log mining directory as to how many processes are to be run. You can kill, you can manage, but trust me, I personally have never explored it beyond this level in logical standby. And like inside the database, of course, you need a query to check how things are working. So this v dollar logical standby underscore stats, this gives us the details about what is happening inside the database. Let us look at this view. I'll go for a max screen. Set lines, triple line. All right, this is what you can see: log miner session ID, number of preparer processes, number of appliers. Can you see applier processes are 5, server processes in use? So it will give you all the details exactly like what's happening inside the log mining, what's going on internally. All right, so this is something you can always look at in order to understand what's happening inside the database.